And a very good morning to our fellow judges and viewers. We are from House Labs, and my name is Choi Kong.
And my name is Arjun.
Today we are going to talk about our innovation towards the current clinical assessment for diagnosing lung cancer types, which are lung adenocarcinoma, LUAD, and lung squamous cell carcinoma, LUSC, through our project Precision Lung Malignancy Profile. Now, moving into the problem statement about lung cancer. To begin with, we're going to chat about the mortality impact of lung cancer. It causes approximately 1.8 million deaths each year, representing about 18% of all lung cancer related deaths worldwide. Now, for future projections, cases are projected to increase by over 60% by 2045, driven by aging populations, tobacco exposure, and PM 2.5 air pollution. Now, late diagnosis equals to low survival. Around 70% to 80% of patients are diagnosed at advanced stages, which are stage 3 or stage 4, resulting in a 5-year relative survival rate of less than 20%. Now, to put this into perspective, at a molecular level of non-small cell lung cancer accounts for over 85% all lung cancer diagnoses.
So, as you can see now, this is our website. And for information, our AI model are trained in Google Colab. Then, we've input the weight and also the AI model through Python into our GitHub. And we've linked the GitHub with this website. So, there are a few main panels in this website. First, which is the 25 gene vector values. We can input this according to the reference table located at the below. So for example, I've input this and it shows me a few important signs. First, which is the criticalness. It will show critically if it is detected as LUAD or LUSC. Then it will also predict the histological type such as the LUAD, LUSC. And another important thing and the specialty of this website is it shows the driver mutation. If you have LUAD and you have a KRAS mutation, it will show here. And also it will show the subtype probabilities on normal baseline, LUAD, and LUSC. And lastly, which is the most important and also the wow factor of this website is the pathway load score. This is critical for oncologists. As you can see here, 0 until 0.250, it shows that it is inactive or controlled. And during 0.250 until 0.4, it shows that there are some background noise in the entered gene sequence. And during 0.41 until 0.65, it shows the early sign of malignancy. And during 0.650 until 1, it shows high purity malignancy. So there are a few challenges that we face in this project. First, which is standard Z-score normalization, flatten subtotal drivers gene spikes, causing early-stage cancers to be classified as a normal baseline. The second challenge that we face is non-malignant samples with broad inflammatory activity causes elevated background gene noises, triggering false positives. To overcome these two challenges, we replace the Z-score with median absolute deviation, which is MET standardization, to suppress background noise. And also, we engineer a dual-subtype triage rule that requires a focal driver spikes to exceed a plus 3.8 unit threshold above background before flagging malignancy. And if you have more time, you'd like to do two improvements. First, which is panel and subtype expansion. We would like to include more rare markers. And second, which is add a multi-sample CSV upload, an automated PDF clinical report export.
I say thank you. Hope to see our project, Precision Lung Malignancy Profiler, succeed in streamlining the medical industry to a new milestone, cultivating a standard, globally validated, and unbiased approach to lung cancer intervention. Thank you all for listening, and I'm open to receive any question down in the comment section below.